Welcome to the second episode of our lecture series in calculus. As we always mention, the main business of the concept of limit of a function is to investigate the behavior of a function at a certain point. In the previous episode, we made use of numerical data to find such a number. Now, we will identify the limit by looking at the graph of the function itself. This method is called graphical approach, another intuitive way of finding the limit of a function. So in the case of graphical approach, our best allies are our eyes. By looking at the graph, we will try to observe where the function goes as the independent variable approaches a certain number. Let's go. Finding a limit of a function using graphical approach. This approach is much like the numerical approach, except that there are no numbers involved, only the graph of the function. We are merely relying on what the graph shows actually. So from the graph alone, we are visualizing a set of values of x values approaching c. Each of these values are projected onto the graph. Such an action is similar to the process of evaluating the function at each of those x values. It's similar to the step 2 of the numerical approach. The computed value of f of x can be visualized along the y-axis this time. The number that these values seem to approach is the purported limit of the function at c. Let us consider the graph of this function. Suppose we are interested to determine where the function goes as x approaches 1. From the left, we are thinking of some arbitrary points that approaches 1. Project this onto the graph, then onto the y-axis. It looks like the points are approaching the number 2, don't they? Let us see what happens when the points come from the right of 1. Project onto the graph, then onto the y-axis again. Once again, it looks to me that these points are approaching 2. What do you think? If you agree with me, then let us claim that the limit of the function as x approaches 1 equals 2. You may have noticed that we're not really sure that or where the function goes exactly. Uh, Nonetheless, this is a fairly good attempt to identify the possible limit of a function, right? Let us try another. Now let us consider a rather unusual function, a piecewise function. Actually, we've considered this already in our previous video about numerical approach of finding limit. Now we are dealing with its graph. And again, this is called piecewise because it is a combination of different functions defined in a particular set of subdomain or interval. I intentionally changed the sketch color of each pieces so that you can easily identify that there are switching of functions in their respective domains. Now let us find the limit of this function at three different points. Limit of f of x as x approaches -2, as x approaches 0, and as x approaches 1. Let us start working on the limit of f of x as x approaches -2. Just like before, we first choose a random points that approaches c from the left. Their positions don't really matter as long as they're coming close to c. Now we want to project them onto the graph of the function, then onto the graph or onto the y-axis. The way these points behave, it looks like they're approaching 0. Let us see what happens when the points come from the right. Project this onto the graph, then onto the y-axis again. These values seem to approach 0 as well. Because the function approaches the same number as x tends to 0 from either direction, we conclude that the limit of f of x as x approaches -2 equals 0. Great, that is how simple it is. I hope you're having fun. Let us try another. This time find the limit of of that same function, but as x approaches 0. We will make this quick this time. Let us assign a set of values of x approaching 0 from the left and from the right, then project onto the graph, then onto the y-axis. As you can see, if you analyze the individual set of values, the yellows and greens, they both seem to point to an upward direction, and they're getting crowded near the number 4, right? So with that observation, we now conclude that the limit of f of x as x approaches 0 equals 4. Piece of cake, right? Alright, so find the limit of f of x as x approaches 1.
What seems to be the problem of using intuitive approaches such as numerical and graphical?
Yes, a numerical approach and graphical approach are effective in getting an insight about the behavior of a function. They seem to work to every function, right? No, There are some functions that do not easily reveal where they are going, no matter how x is made close to c. For example, if 1 is to find the limit of 1 plus x raised to 1 over x as x approaches 0 using numerical approach, then he will end up feeling frustrated because as x grows, f of x also grows non-stop. Look at this. We start with 2.8679 becomes 2.73199, 2.796. It doesn't really give us a pattern of where it is going. Unlike before, the values or the limit that we computed using numerical approach. In this case, no conclusion can be made in terms of nominating a value towards which the function seem to approach. Actually, it takes a more advanced method in order to get around this limit problem.